We're going over the Part B2 of the Living Environment Regents Exam that was given on June 13th, 2018. So let's flip to that page. So we've got a story about moose killing winter ticks. So it says the moose killing winter ticks. Moose habitat is determined by temperature. Moose prefer areas where the average summer temperature is around 15 degrees Celsius and does not exceed 27 degrees Celsius for too long. The reason for this temperature dependency, moose cannot sweat. Beside the cooling effect of water, which moose are almost always near, aquatic environments provide them with a good supply of food and in the past have protected them against biting insects. However, the North American moose population is facing a new threat, a parasite called the winter tick. These ticks lodge themselves in the animal's fur and hold on through the winter, sucking the animal's blood. Many infected moose end up dying of exhaustion and weakness as a result of the large number of ticks feeding on them. Ticks are most active during dry days in the fall. Adult ticks that drop off moose in the spring and land in the snow cover have a poor survival rate. Climate change can be predicted to improve conditions for winter ticks due to longer and warmer falls, the earlier snowmelt in the spring. Surveys of the moose population in northeast Minnesota have recorded the change shown below in the moose population between 2005 and 2013. So here's my data. And next they're going to ask me to graph this data. So if we take a look at the graph that's given, they already have the years laid out here for us, so we need to then put a scale here for the estimated moose population. So the data range goes from 2,760 at the bottom up to 8,840 at the top. So we need a pretty big data range scale. A couple of different choices that you could go with. You could choose to start your scale from 0 and then go up by 1,000. So you'd end up with 0, 1,000, 2,000, 3,000, 4, 5, 6, 7, 8, 9. And that would get you up to this line right here. That leaves a lot of blank space, and typically on the grading key, they don't like to see a lot of blank space. So we want to consider going from a number that is not 0. So if we look at the range that's given, the 2760, if we start our range at either 2000 or 2500, that'll give us enough space to go up to 9000, which is just above our highest range, and that's what the answer key would like to see you do. So on the answer key that's given on the Regents exam, they give us 2500 as the origin point here. I would have gone with 2000, but it's okay to go with 2500. It goes right below the data range that they give you. And then you just have to be really careful to make sure that you go up by the same increment each time. You also want to be careful to make sure that your numbers line up properly. So this can get a little cramped. You could even skip a line and go to 6,000, skip a line, go to 7,000, skip a line, as long as you're really good at making sure to skip the lines properly. If you feel like it would help you to label every line and it'll be a little easier. Now we have to actually plot the data points. So this is a look back and forth, plot each point. So in 2013 we had 2760. 2013, this is 2500, this is 3000, so right about in between is our 2760 mark. And I'm not quite sure why I started at the bottom of the data table, but let's go back to the top of the data table. So in 2005 we had 8,160 moose. So here's our 8,000 mark. Remember, this is 8,500. So we're gonna look, let me just double check, that was 2005. So over here, we're gonna have right about there is our point. Doesn't have to be picture perfect. And then make sure to circle your data points as you do them. I'm going to save you the aggravation of watching me plot each and every one of the points, and I'm just going to show you the final product looks like this. Now, it was easy for them to make the numbers nice and small because they're using a printer, but you get the idea. Other things to make sure to watch out for. If you look at how these points are connected, they're connected very precisely, one to the next, one to the next. There's no wiggliness. There's nothing before the first point, so they give you all this blank space here. Don't fall for the temptation to connect it down to 0. Just keep it where it is. Don't try to interpolate by drawing a line out that way. Just whatever your data points are, use those data points. And then this one here as well. Stop where the data point is. Don't go any further. Don't extrapolate or interpolate out your data. All right, the next question is about the moose population and the graph that you just answered. So it says, explain how climate change could result in an increased number of moose infested with winter ticks. So one of the things that you have to come to this with is knowing that when we talk about climate change, typically we're talking about the climate getting warmer. So we want to know, how is warm weather going to affect the tick population and how many ticks are on the moose? And if we go back into the reading passage, you'll see, first of all, climate change can be predicted to improve conditions for winter ticks. That should give you a clue that your answer needs to include there being more ticks, not less ticks. So what makes it better for the ticks to survive? And they give you the information right here. It says ticks survive better when you have no snow cover. So if you're having warmer springs, there's not as much snow, the snow doesn't last as long, the ticks can survive when they fall off. Also, having warmer falls is going to give them more time where they can survive as well. So your answer should include information about the warm weather being good for the ticks, and the reason it's good is because of less snow and warmer weather. So the answers on the answer key that are given here are that falls are longer and warmer, increasing the chances of the tick survival and infesting the moose. You could say climate change can be predicted to improve conditions for winter ticks through earlier snow melt in the spring. So if the snow is melting earlier, the ticks get to survive when they fall off. And that ticks fall off the moose into soil instead of snow and will survive. So just something that tells me about more ticks surviving because the weather is warmer and better for them. All right, so I'm going to keep going on a new video. That way this one doesn't run too long.